Alright, so here's the first video explaining the precession of the Earth. Great. So now we're going to watch the second video. We already watched a little bit of it, and it does do a very good job at showing you the relationship of the Milankovitch cycles and the temperatures observed quite well. So pay attention to the graphs that they are kind of drawing with the cycles within the video. It also incorporates a little bit of what we talked about in terms of the isotopic measurements. So pay attention to that as well. I'm going to stop the video at the point where it starts talking about crustal rebound, which we already talked about.
Once upon a time, only a moment ago really in the grand scheme of things, the Earth was a very different place. Her continents were covered with thick ice sheets that scoured the landscape into new and fantastic landforms, and ocean levels were low with all that water locked up in ice. This was the last glacial maximum. It had happened before, several times, all throughout the current ice age, which began 2.6 million years ago. Tugged by unseen forces, Earth constantly squirms in her orbit, shifting the tilt of her spin axis and nudging the shape and orientation of her elliptical path. All of these changes happen at their own assigned frequencies, and they all add up to a pattern of more and less light received from the sun, more and less intense seasons.
So this,
when temperatures are low enough, more and less light received from the sun, more and less intense seasons.
Overall you get in terms of the solar heating. You see that certain periods cause greater heat, some of them cause lesser heat or colder temperatures overall.
When temperatures are low enough, more ice accumulates during the winter than melts during the summer, and permanent ice sheets can grow. This temperature record is written right into the ice. The annual layers of deposited snow capture different amounts of oxygen-18, a much less abundant, heavier cousin of typical oxygen-16, and that depends on the temperature. We can measure these differences in ice cores and reconstruct hundreds of thousands of years of climate history.
So overall, this graph is what they were able to determine based on both the oxygen-16 to oxygen-18 ratios, and as well as, again, some of the concentrations in the CO2 within the atmosphere at which those ice layers formed. And they were supported by the glacial interglacial periods determined by the Milankovitch cycles. Alright, so with both of those hypotheses, one being the plate tectonics one, and one being the Milankovitch cycles to explain the glaciation causation, we can explain relatively well the onset of glacial conditions and different times in geologic history thanks to the plate tectonics hypothesis, and then we can explain the glacial and interglacial cycles seen during the Quaternary period thanks to the Milankovitch cycles. So there are other causes that help explain the magnitude of the temperature changes that occurred during the most recent ice age, however. One of the factors influencing these temperatures involves the variations in the composition of the atmosphere. So we already talked about a little bit how we can measure the variations in the atmospheric concentrations by the tiny pores that are within the ice, but the actual variations come from a phenomenon referred to as the groundhouse effect. We'll talk about the groundhouse effect in depth when we cover climate change in chapter 20, so I won't cover it here, but basically, for the purpose of this lecture, the greater amount of greenhouse gases that there are in the atmosphere, the warmer that the Earth will be. Another factor that has to do with the Earth's surface reflectivity also impacted the temperature observed. So this factor is also called the albedo effect, and this is how well will the Earth's surfaces re-radiate the energy back to space from the energy that radiates from the sun. So certain materials and colors within the atmosphere will re-radiate the energy back to space better than others. Some of them will absorb this energy, some of them will absorb it to a lesser amount, some of them will re-radiate it greatly. So we'll also cover this more when we talk about climate change, so I won't go in depth here either. But summarizing it and here making a few assumptions, the lighter colored surfaces will re-radiate that energy back into space better than the darker colored surfaces. Okay, so a place that was covered with snow re-radiated the energy much better than a place that has no snow at all, basically. So lastly, another factor that has to do with changes in ocean circulation also affected the temperature seen during glacial and interglacial periods. So both warm and cold currents carry waters throughout the sea. And these waters have an effect on the surface temperatures observed at those sites and on the temperatures that the nearby rocks will receive. So overall they will have an effect on possible glacial temperatures that are needed at those sites. So overall, all of these possible explanations that I have mentioned in the last few slides do not represent the only possible reasons for ice ages, but they are attractive and they are interesting. And although they have their own flaws, they're decent at explaining what we have seen thus far. That doesn't mean, however, that other factors could not be responsible as well, and that could be involved into the scheme of things. All right, so with that, we are done with chapter 15, and as always, please let me know if you have any questions. I hope that you enjoyed the material and the lecture, and I will see you when we cover climate change.